In this problem, we are asked which of the following could be used to conclude congruent segments. The reflexive property of congruence can be used to show two segments are congruent. This property is used when two triangles share a side. We can draw a quick pic just to represent this. If the two triangles share this side that I've done in purple, we could use the reflexive property of congruence to mark that segment congruent to itself. The definition of midpoint can be used to conclude two segments are congruent. So if I have a segment and I am told that I have a midpoint, so I'd have to have the word midpoint, I can conclude that this piece is congruent to this piece. Definition of perpendicular bisector can be used to conclude congruent segments. So let's draw a quick pic. If I have a perpendicular bisector of a segment, I know if this is the perpendicular bisector, let me do this in orange. If the orange segment is the perpendicular bisector, then this intersects at the midpoint, and I can conclude that these two segments are congruent. Definition of segment bisector can also be used to show that two segments are congruent. If we have a segment bisector, and it could be a line, a ray, or a segment that is bisecting the other segment, we know that it is breaking it into two congruent parts. So again, we can conclude that these two segments are congruent. Definition of angle bisector cannot be used to show that two segments are congruent. This would be that two angles are congruent. Vertical angles are congruent cannot be used to show segments are congruent. It says vertical angles, so this is used to show two angles are congruent. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Again, we're referencing angles are congruent. So this is that two angles are congruent. And our final choice, if two parallel lines are cut by a transversal, then corresponding angles are congruent. As it says in the sentence, it is showing that two angles are congruent, not two segments.